Hello everyone, I hope you are doing well. So in this video, we're going to discuss the solution to all the problems of code forces round 886, which was rated for division 4. So the overall round was pretty much balanced and it was good enough for a div 4 round, and we're just going to discuss all the problems. It is going to be a very long video, so let us quickly start with the first problem. So this first problem says that we have been given 3 digits A, B and C, and we have to tell if we can choose any 2 digits to make the sum greater than or equals to 10. Right? If it is possible, then we have to print yes, otherwise we have to print no. So I don't think there is much need of discussion in this particular problem, because what you can do is, if there are three digits, then you can take the maximum 2 among them and try to make their sum greater than or equals to 10. If the maximum 2 among these 3 digits cannot make a sum greater than or equals to 10, then it is obviously not possible with the smaller numbers, right? So this was all about this particular problem, and let me just directly show you the code. How I implemented it during the contest was, I took 3 integers as input in a vector, I sorted the vector, and I took the last 2 elements. If their sum was greater than or equals to 10, I just print yes, otherwise I print no, right? So this was the solution to the first problem. Now let us have a look at this second problem. So this particular problem says that we have been given some participants from 1 to n, right? And each of their response is AI words long and has quality BI, right? So for example, these are the participants. There are 5 participants and each participant has AI and BI written in their input. Now we have been given a limit of 10 words. So we have to make sure that each participant has the number of words less than or equals to 10, right? Among all these participants, we have to tell the participant which has the greatest quality. So let me just explain you this with the help of an example. If you take the first test case, if you try to take this particular test case, the answer is 4 that they have mentioned. So as you can see, the limit that we have is 10, right? So the first participant has a valid, so this first participant has a valid entry, right? We can say it like this, that this participant has a valid entry. Now this participant has an invalid entry because the number of words is greater than 10. This participant has a valid entry because the number of words is less than 10. This is also valid, and the last one is also valid, right? Among all these participants, we also see what is the quality of their work, right? And among all these participants, we have to tell the participant with the greatest quality. So in this case, 1, 2, 3 and 4. So this is the participant with the quality 4 and this is the greatest value. So we have to print 4, right? This is all you had to do. So basically what you can do is, you can keep track of what is the best value, right? If the current participant is a valid participant, that means he has the number of words less than equals to 10. If words is less than equals to 10 and its quality is greater than the best quality that I have achieved till now, then I can update my best as, best will be updated as new quality and my answer will be updated with my current index, right? So this is all you had to do in this particular problem. So let us have a look at the code. So you see what I've done is, I've created an integer n and I've created 2 variables best and answer. So best is initialized with 0. Now I just traverse through all the values and take inputs. If the number of words is less than or equals to 10 and the new value that I have got is greater than best, then I'll update the value of best and I'll update my value of answer. So I've taken I plus 1 here because this indexing is going from 0 and in the answer we have to print 1 base indexing, right? So at the end I can just print my answer value, and this would be the solution to the second problem. So let us have a look at this third problem. This particular problem is also very simple. It is just saying that we have been given an 8 into 8 grid of dots and we have to print a word, right? And that particular word is present in this particular 8 by 8 grid. Also, that word is present in a special manner. So they have mentioned it here. The word lies entirely in a single column. It is continuous from the beginning to the ending without any gaps. So in one of the columns, there will exist that particular word, and one more very important thing, that the word will be continuous, right? There will be no gaps in between and there is exactly one word in the grid. So basically, if I like show it to you in the form of a grid, this is one cell, right? So this is how a grid will look like. Now most of the elements will be having dots, or the most of the cells will be having dots. Now some of the grids will have some characters. So let's say this particular cell has a character C. That means there is a word that is going to start from here, provided that this is also dot. Right. If I know that this is the first character of my string, then all the other characters should follow directly below it. Right. And there should be no gaps in between. So what I can basically do is I can find the first character and just try going downwards. Right. As long as I find new characters, I can try going downwards. And as soon as I encounter a dot or I move out of the bounds of the grid, I can just break my word formation. Right. So this was also very simple. It's just a simple implementation problem. So let me just show you the code how I did it. So basically, I created a double dimensional vector of size 8 cross 8 and I'm taking input in the vector. Now I'm just traversing through the vector. As soon as I encounter this particular state where v of ij is not equals to a dot, that means there is some character. I initialize my answer with an empty string and I initialize my index with I. While index is less than 8 and the character at this particular index comma j is not equals to a dot, at that particular moment I can add that particular character to my answer. Also at the same time I'm incrementing the value of index. Since I want to increment this value of index after adding the character, I'm using post increment. Right. After it I can just print the value of answer and I can just return from this function because there will be exactly one string. So at the end I just printed a new line here. That was just for example, if all the characters in the grid were dots. But I believe that should not be the case and this condition will never get triggered. The question is like you will get exactly one word in the whole grid, right? So this was all about the third problem. Now coming on to the fourth problem. This particular problem says that we have been given n problems and each of the problems has a difficulty ai associated with it. Now what we have to do is we can remove some of the problems from the list. The first point says that we can remove some of the problems from the list and rearrange the remaining problems in any order we want. So we have to remove some of the problems from the list, and what is the condition that we have to maintain? We need to maintain that the absolute difficulty between any two consecutive problems should be at most k or less than equals to k, right? So basically if we have two problems consecutively, then their difference should not be greater than k. Now we can rearrange the problems in any order, so this problem becomes a lot easier. So let us have a look. Now if I have some problems, let's say a, and then I have a plus k, and then I have a plus 2k. So you see all of these problems, these two problems have a distance of k, these two problems have a difference of k as well. Now as soon as I include some value like this, so these two problems have a difference of 2k, right? Now again I might have some other value here, a plus 5k, a plus 6k, right? Again this is difference is k, and let me just also write a plus 7k, so that this difference is also k, right? Now you will see that if I have a situation like this, if I have some similar situation, so these three elements are going to form one single group and these four elements are going to form another single group. But the problem is I cannot take both of the groups together because these two elements have a difference which is equal to 2k and which is in fact greater than k, which is not allowed. So the only choice that I have is to choose one of these two groups. So basically the whole idea is to divide the array into groups like these such that the consecutive element in each group has a distance of at most k or a difference of at most k. Now when we divide the array into some groups like these, you will see that we can only take one group at a time, right? We cannot take all the groups. Why we cannot take all the groups or even more than one group? Because if we try to take more than one group like this, you will see that the difference is going to be greater than k, which is not allowed. So if the maximum size of the group is x, let's say, and if I am able to find this value of x, then definitely I'll try to choose this group. Why? Because if I choose this particular group and I remove all the other elements that are not in this group, then I have to remove n minus x elements, right? So basically I am going to choose the biggest group and I am going to remove all the elements that are not present in this particular group. This is our whole idea. So for this value to be minimum, for the number of elements that are to be removed to be minimum, now before before trying to divide the whole array into groups, we need to make sure that the array is in sorted order. Why sorted order? Because let's say we have something like this. Let's say this is 4 and then we have 5. So you see that the difference between these two elements is currently 2 and the difference between these two elements is currently 3. The maximum difference that is allowed is 1. But here you will see that if you try to apply this particular same logic here, this array will be divided into 3 different groups, right? The groups will be like this. But since the problem says that after removing some elements, we are free to rearrange the elements in any order we want, then why not arrange the elements in the beginning itself? So if we rearrange the elements in sorted order like this, you will see that now these two elements have a difference of 1, these two elements have a difference of 2, right? So this is how you can try to minimize the difference. If you just sort the elements, the consecutive elements will always have the minimum difference possible, right? So if this difference is less than equals to the maximum allowed value, then this is going to be one group. So here you see that there are 2 groups instead of 3. So that is why you need to sort your array before doing any such operation. So let us have a look at the code now. So you will see what I have done is I have taken 2 input integers n and k and I have created a vector v and taken input in the vector and sorted the vector. Now I initialize my 2 values, best, current. So best is going to store the biggest size that is possible of a group and current is going to store the current size of the group. And I have initialized my index with 1. So while index is less than n, I check what is the absolute difference between the current element and the previous element. If this difference is greater than k, then I am going to update my best answer, which is going to be the best maximum size, right? And after updating it, I will update the value of current as 1. Also, if it is not true, if this condition is false, that means the current element and the previous element are within permissible limits. So I can increase the size of the current group, and in any of those cases, I will increment the value of index. Now at the end, I can just again put out this condition, best is equals to max of best comma current, because there might be a case where the last group is not recognized or the last group is not included in my answer. So at the end, after I have found the size of the biggest group, I can just print n minus best. So this would be the solution to the 4th problem. Now moving on to the 5th problem. So this particular problem can be solved with binary search. I'm telling you this particular thing beforehand because if you have already studied binary search and answer and for some reason you were not able to solve this problem during the contest, then I highly recommend you to solve this problem first using the idea of binary search and answer. And if you're still not able to solve, then anyways we are going to discuss this in this particular video. So the question says that we have been given some paintings like this and each painting has some size. So this all of the paintings will be in square and the side of the square is given, right? Now we have to make a cardboard which will hold the painting. So it is basically like a frame. Now this cardboard goes all the way around the painting as well as behind the painting. So let me first do some basic setup for the problem. Let's say this is our painting and this has a side of size 3 units. Now there will be some border around the painting of cardboard, right? Let's say it has a width of 2 units, right? Now 2 units on this side and 2 units on the upper side. So the total side of the cardboard will be equal to 3 plus twice into 2 whole square, which is 4 plus 7 square is equals to 49, right? So this is the total amount of cardboard used on this particular painting. Now they say we have been given an array A where A of I denotes the size of the ith painting. Now each of those painting always have a fixed amount of width border equals to W. We've also been given the total amount of cardboard used as C. Now we have to find the exact value of W, and the constraints of the question have mentioned that the input is such that there will always exist a value for W, right? We have to find this particular value of W according to the given array A and the total amount of cardboard used. For each painting, the total amount of cardboard used would be the side of the painting plus twice into width of the border whole square. right? So this would be the value for each of the paintings, and if you do summation for each of those sides, then it should be equal to C. This is our whole question. Now how can we solve this? We already have this particular equation. We're going to do it with binary search, but even with binary search, I would say that there are always many different methods to solve the same problem with binary search. So we are going to discuss one of such possible methods in this particular video. Now let me set a premise for my binary search condition. Right. My premise is I want to find a value. I want to find the smallest value of width such that this particular value summation of side of I plus twice into width whole square is greater than equal to C. Right. I want to find the smallest value W such that the summation of this particular expression is greater than equal to C. This is my premise that I am setting. So according to the question, there exists integer value of W. Integer value of W. So if they are already saying that there exists an integer value of W, and if I try to find the smallest value of W such that this condition is satisfied, I will eventually get a value of W such that if I calculate the same expression side of I plus twice of W whole square, it will be equal to C, right? Let me repeat it again. If I am trying to find the smallest value of W such that this expression is satisfied, and they are also saying that there will always exist an integer value of W as an answer. So if I try to find the smallest value, I will eventually get a value which will satisfy this particular expression. And this is exactly what I want. So how will I form this is, first of all, let me just set a base case. What if the value of W is equal to 0? In this case, summation of side of I whole square should be equal to C. If this is not equal to C, that means I can set my low is equal to 0. Right? If this is equal to C, my answer will be 0. Otherwise, I will set my low is equal to 0. Why low is equal to 0? Because I have already seen that the answer does not exist for 0. So if I set low to 0, I can surely say that answer will never exist at this point. Never exist at this point. Now I want to find a value of high such that answer will always exist at this particular point, right? Such that the value is always true for this particular point and the value is always false for this particular point. So how do I find a value of high such that it is always true? Let me take a corner case. You will observe that in the worst case, the size of the painting will be 1, right? Plus I will have some width, so it will be twice into x from here. And if I do it square, it should be equal to 1e18 or 10 raised to the power 18, which is the maximum possible value of C according to the constraints of the question, right? So this is roughly 10 raised to the power 9 minus 1 divided by 2. This is the value of x, right? I can say that x is equal to roughly 10 raised to the power 9, right? So if I can set my high as 10 raised to the power 10, then I can surely say that if I take my high as this particular value, the answer will always exist. Answer will always exist. Now I can just do simple binary search, and for each value of mid, I can find out whether this summation value is greater than equal to C or not. If it is greater than equal to C, if the value of summation is greater than equal to C, then I will update my high as mid, because at this particular point mid the answer is possible. Otherwise I'll update my low as mid, because at this particular point mid the answer is not possible. Since the value of high always consists of the correct answer or a valid answer, I can just at the end print the value of high. So let me show you the answer, how I did it. So you will see what I have done is I have taken two integers n and c as input, and I have taken a vector v of size n. So what I am doing is I am initializing the sum value with 0, and I am trying to calculate the sum when the value of w is equal to 0. If this is true, then I can just directly print 0 and return from here. Now if this is not true, that means the value 0 will never hold a true answer, and it will never be one of my possible answers. So I initialize my low value with it. Now I initialize a high value with some value which I believe can always be the answer, which is the maximum upper bound. Now I do my simple while low is less than high minus 1, and I calculate the value of mid. Now I have my checker function here, and if check returns true, high will be equals to mid, otherwise low will be equals to mid. How do I actually check it? I'm initializing a 128-bit integer. So this particular value was actually giving me overflow for some of the values. So I decided just to take 128-bit integer so that it does not overflow. You can also take it, but just make sure that you are using a 64-bit compiler while compiling your code locally as well as submitting online on Codeforces. You will see here, you can check it out here. You see that this is C++ 17 64-bit, right? You have to make sure that this is 64-bit, otherwise this 128-bit integer will not work. Now what I do is I just traverse to this value of p and I just add all of these values, which is I plus twice of mid. I multiplied by same value so that I can take it square. Now if this particular value is greater than equals to c, then I can just return true based on this expression. Otherwise it will automatically return false. After this loop has been completed, since my high always stores the correct value or a valid value, I can just print high. So this was all about this problem. Now let us move on to this problem F. So this particular problem, I would say that this is a part of number theory, and if you have studied this particular thing, then you would have solved it very fast. But if you have not studied it, it would take you some time to realize what will be the actual time complexity of this particular problem. So the whole idea was to mark the multiples of each number, and we will see how it can be done. So first let me explain you the problem. They say that we have been given n frogs and each frog has some value associated to it. So what is this value actually denoting? This value is denoting that this frog can only make jumps of size ai, right? So for example, they've also explained it here, and let me just explain you this first sample test case. So if they're talking about the first frog, then it can make a jump of size 1. So it can go from 0 to 1, then 1 to 2, then 2 to 3, then 3 to 4, 4 to 5, and so on. The second frog can make a jump of size 2. So this frog can go from 0 to 2, then 4, and then 6, and then 8. If you talk about frog 3, it has a size of, it has the jump of size 3. So it can go from 0 to 3, then 6, then 9, and so on. Similarly for 4 and 5, for 4 it will be 0, 4, 8, and so on. For 5 it will be 0, 5, and 10, and so on. Now they are saying that they can place a trap. So we can place a trap at any one of those positions from 1 to n, right? Now we have to choose the position of the trap such that it can take the maximum number of frogs. So for example, if I choose the value or the position of trap is equal to 4, in this particular case, you will see that 4 exists here because frog 1 will land on this particular position 4. So this frog will get trapped. Now 4 also exists here. So frog 2 will land at this particular position. So it will also get trapped. 4 is also present here, and these are the 3 frogs that will get trapped. And 3 is the maximum answer that I can form in this particular case. So this is how you have to solve this particular problem. Now if you have already had studied sieve and the applications of sieve, then you must be already familiar with the technique where we mark the multiples of any particular number. So that particular technique basically helps us to find the divisors of any number n. So we can use this particular method, but to our advantage in this particular case. Instead of just finding the divisors, what we can do is for each input a of I, we can find its multiples and increment its frequency. For example, if I have a number 2, I can increment the frequency of 2, 4, 6, 8, and so on. So let's say their frequency was initially 0. Position 2 has a frequency 0, it will get 1, this will also get 1, this will also get 1, and if the frequency of position 8 was initially 1, so it will get updated to 2. So these values are denoting that if I place a trap at position 2, one of the frogs will be trapped. If I place a trap at position 8, two of the frogs will be get trapped, right? So this is nothing, just a simple for loop. And let's say we have some value of I is equals to ai. Now I'm going to again initialize a for loop, and this will be from j is equals to I, j is less than n, and j plus is equals to I. Now the only problem that you might have faced while thinking of the solution is, you might worry that this is an n square solution, but it is not actually an n square solution. So while solving this particular problem, when we generally find the number of divisors of any number, the first for loop is like this, starting from 1, I is less than n and I plus plus, right? And the second for loop is j, starting from I, j is less than n and j plus is equals to I, right? So this is the same type of for loop that we are going to use in this particular problem, and this looks like an n square loop, but it is actually n log n. So if you have studied sieve, then they just mention it there that this similar loop is n log n. So if you have studied it, then you must have already knew that this is n log n and you would have done it directly. But in case you have not already studied it, then let us have a look why this is n log n. I'll just try to give you a slight intuition of it. So when the value of I is equals to 1, you are going to increment your j 1 by each time. So it is going to visit all the n nodes, right? When the value of I is equals to 2, you're going to increment your j by 2 each time. So you're going to visit n by 2 nodes. When your value of I is 3, you're going to increment your j by 3 each time. So you're going to visit n by 3 nodes. And so on, this particular thing continues up to n by n. Right. If you take n common out of this particular value, then it will be reduced to 1 by 2, 1 by 3, 1 by 4, 1 by 5 and 1 by 6 and so on. So if you try to plot a graph of this particular equation, it will start from 1, right, and it will decrease logarithmically, right, like this. So with the help of this graph, I'm just trying to give you an intuition that this particular part will always work in log n, right? If you try to form a graph of this particular area or expression, it is going to form a logarithmic graph like this, right? So the overall expected time complexity is n log n. So what you essentially have to do is, for each number given in the input ai, we can map all of its multiples. Now to make it even better, what we can do is, we can count the frequency of each number ai. So for example, if 1 is present 3 times, I don't need to run a loop for 1 3 times. What I can do is, I can just run it 1 time, and for all the multiples of 1, I can increment their frequency of j, let's say, by 3, right? So instead of going through the multiples of 1 3 times, I can just increment their frequency by 3 at once only. So let me just show you the code for this particular problem now. So you will see it here. What I've done is, I've created a traps vector which is going to have all values initialized with 0, and I've also taken input in the vector v, and I've also initialized a map f which is going to store the frequency of all the elements. Now I'm just traversing through the map, and I'm starting from j is equals to I dot first until j is less than n plus 1. I'm just going to increment the value of j by I dot first each time, and this value of traps of j is going to get incremented by I dot second. So I believe understanding this part is not very difficult. It's just that a lot of people might get confused about the time complexity of this particular part, because it looks like n square, but it is not actually n square, it is n log n, and that is why you need to be aware of this particular thing. Other than that, if you already know this thing, then it is not very difficult observation to do this particular part, and at the end you can just take the maximum element among all the values in the traps vector. So I'm just taking max element, and I can just print it. So this was all about this particular problem. Now let us move on to the next problem. So this problem is also very simple observational and implementation problem. So let me just explain you with the help of some cases. They're saying that we have been given a compass and it can point successfully in 8 directions like these, right? So let's say we have been given some n coordinates, and let me take x1 y1 and x2 y2. So let's say this is my compass and this is some planet P, right? So my compass is always pointing towards this planet. So let's say my compass is here. Now I can have my planet at this position like this. So if this direction is a straight line, right? Straight line means out of these 8 lines, if it is one of the lines, then my compass will be able to point towards it. Otherwise, it will not be able to point towards it. So this is one point. Now the planet can be here also. So this direction has to be like this. So this is northeast. This is also valid. But let's say if I just draw the coordinates like this is northeast direction and the planet is at this particular position, then I cannot point towards it and it will not take and it will not count, right? So this is the setup of the problem. Now if my compass is like this and it is successfully pointing towards the planet in this particular direction, let's say this is east, then if I just invert their position, this becomes the planet and this becomes the compass. So it can also point in the reverse order and this will be in the west direction. So if one pair is possible, their inverse is also possible. That means if I can write a pair like AB, BA will also be possible and both of them will be valid pairs. If one of them is valid, the other one will be valid. So how can we solve this particular problem? Now let me just construct any line. Let's say this line is pointing in northeast direction. It is going from southwest to northeast, right? Let's say I have my first point somewhere here. As soon as I encounter my second point on this particular line, what will happen? This point can make a pair with this particular point. So 2 will get added to my answer because I have already told you that A and B can be written like this and BA can also be written like this. This is also valid. So that means if I have a point here, I will add the answer according to the points that have been encountered before it. Now if I have some other point after it, now this point can pair with this particular point and this particular point as well. So 4 will get added to my answer, right? So basically what I am trying to say this is, if these points are on the same line, then each time let's say a new point is added. So let's say this is the fourth point, then I have to do 4 minus 1 multiplied by 2, because this particular fourth point will form a coordinate or a valid pair with these 3 points and its inverse is also possible, so it will get multiplied by 2. So I am trying to explain you what happens when you keep on adding new points to a line. How are we actually going to find whether the new points that are being added on the same line or not? So we can try to solve this independently for all the 4 lines. So if you see carefully, there are exactly 4 lines in this question. So one line is like this, one line is like this, one line is like this, and the other line is like this. So each of those lines have a definite slope and we can try to find the value or the number of points like these or for each of those 4 lines. So for this horizontal line and this vertical line, it is easy. So let's say if I talk about the vertical line, then you will see that the x coordinate is constant, right, and the y coordinate will only change. Similarly for this horizontal line, you will see that the y coordinate is constant and only the x coordinate will change. So if I have encountered any particular point, let's say 2, 3, and I want to find how many other points are there on this same horizontal like this, what I can do is I can find the number of points which have a y-axis equals to 3. Similarly, if I want to find the number of points which are at the same vertical axis like the current point, for example, if it is x comma y, the current point is x comma y, and if I want to find the same number of points on the same vertical line, then what I can do is I can find the number of points which have the x-axis equals to x, right? So those will be the number of points. Now this was about the horizontal and the vertical line. What happens if I talk about this particular line? So you will see if there is some point x1 and y1 here, what will be the point after it? The point just next to this point will be x1 plus 1 comma y1 plus 1, right? The next point after it will be x1 plus 2 comma y1 plus 2, right? So this is what will happen when all the points are on this straight line like this. which is running from southwest to northeast. So if I am at a point and I try to move a point just next to it, so it will be x1 plus 1 plus y1 plus 1. So you are saying that after some distance d, the coordinates will change to x1 plus d comma y1 plus d. And no matter what distance I move, the difference between these two coordinates will be y1 minus x1. So if I am at any coordinate, let's say x comma y, I can just try to find how many points have already existed which have a difference y minus x, because this difference is not going to change for all the points on a single line, right? Similarly, I can try to do the same thing for a line like this, which is running from northwest to southeast. Now what will happen in this particular case? If this is x1 and y1, the first point is x1 comma y1. If I try to move out to a point just next to it, remember I am saying just next to it, then what will happen? This x coordinate is going to get increased by 1 and this y coordinate is going to get decreased by 1, right? So if I move one more point to the next, my x coordinate is going to increase by 1, so it is x1 plus 2, and y coordinate is going to decrease by 1, so it is y1 minus 2. So in this case you will observe that the sum, in the previous case it was the difference, but now the sum is always going to be the same. So the sum is going to be x1 plus y1. For this particular coordinate, if you see, if I add both of these values, it will come out to be x1 plus y1. So if I am at any general point x comma y, I can just try to find how many points I have encountered till now which have a sum x plus y equals to the current sum, right? So this is how you can solve your answer for all four of the lines independently. The first part was, let me just explain you this particular problem once again, because this might get a bit complex. The first part in this problem was to identify what happens when we add a new point to the line. So let's say this is a straight line, and let's say I add the xth point. So the value it will get added to my answer will be answer plus is equals to x minus 1 multiplied by 2. Why? Because this particular xth point is going to get paired with x minus 1 other points, and for each pair the inverse is also possible, so it is getting multiplied by 2. Now that I have figured this particular part out, I need to figure out what are all the points on the same line. So for finding all the points on the same line, I have divided the same problem into 4 independent tasks for 4 different lines. For the vertical line, the value of x should be constant. For the horizontal line, the value of y should be constant. For this line running from southwest to northeast, the difference between y and x should be constant. And for this particular line running from northwest to southeast, the sum of the coordinates should be constant, right? So this is how you can solve this problem for all 4 of the lines independently. You can find your answer. So let me just show you the code for this particular problem now. So what I have done is I have created a vector of pairs and I have taken input in the vector, and I have created 4 maps. So this is basically going to store all those 4 values and I am going to count it. So I am just going to initialize my answer with 0 and traverse to the map, and for the map f1 I am going to store the difference, for the map f2 I am going to store the sum, for the map dx I am going to store the x coordinate, and for the map dy I am going to store the y coordinate, right? So if this value is present in my f1 map, so what I will do is I will add this value multiplied by 2. Similarly, if this value, the sum of the values is present in f2 map, I am going to add that particular value multiplied by 2 into my answer. If this x coordinate is present in my dx map, then I am going to add this particular value multiplied by 2, similarly for dy as well. And after all the coordinates has been updated, I will update their frequency in the map as well. I am going to update the contribution made by the current point so that it can help the next points. Now at the end I can just print my answer value. So this was all about this particular problem. All you had to do was make an observation on what happens when we add a new point to our current line, and how can we find all the points that are associated with the current line independently of each other, right? So let me discuss the solution to the last problem. So this particular problem can be solved with graph, and we are going to discuss how it can be solved with a simple DFS. So what this question basically tells us is, there are n soldiers and we are going to arrange them in a specific order, and each of those conditions will be given in the form AI, BI and DI, right? So each of the conditions will have 3 values, and it says that the camp of the soldier AI should be situated DI meters in front of the camp of the person DI. If DI is less than 0, then AI's camp should be DI meters behind DI's camp. So basically, let me just explain you. If this is person A and this is person B and this is value D, I am saying that this person camps should be D meters in front of B person's camp. So if B's camp is here, I can move D meters in front of it and A person's camp should be here. I can also say that B's camp is D meters behind A's camp. Right. So if I'm adding an edge from B to A with a distance D, I can also add an edge of minus D from A to B. Right. So there will be multiple conditions like these, and we just have to tell whether all of these conditions are consistent among each other or not. So I have said it in a very simple manner. The question actually said that we have to find whether this particular arrangement is possible or not, and it implies the same thing, whether the given statements are consistent or not. So what we can do is, the very simple idea is to first of all form a graph like this, right? So if I am adding both of the edges, it doesn't actually matter if I add an edge from B to A, right, like this, or if I add an edge from A to B like this. If I write D here, it should be minus D here, and if I write minus D here, it should be D here, right? You can do it any of those ways. It's just that if you're doing it in one of the ways, it should be consistent across your whole graph. So what you're going to do, you're just going to make a DFS on all unvisited cells or all unvisited nodes. Whenever a new node or a child node is not visited, if it is not visited, you can update its distance of child will get updated, right? And you can make a DFS call to the child. Otherwise, if it is already visited, then what you have to do is, you have to check whether the distance that the child has is consistent with my current distance that I have calculated. So let me just write it as calculated. So if it is already visited, then I already should know what is the distance that the child has. If I am at a current node and I know what is the distance that I have to go to traverse to the child node, then I can also calculate the correct distance. If these two values are not equal at any point in my graph, that means my graph is not going to be consistent and the answer will be no. If this value is consistent across all the edges, then the answer is going to be yes. So this is just like checking for a bipartite graph. It is somewhat similar to that. We have an expected value that we have for each node, and we have a calculated value that we have for each node. If these two values does not match, that means we don't have correct graph, right? So this logic is somewhat similar to checking a bipartite graph. So let me show you the code. It is not very difficult. So what I have done is, I created a graph which is a double dimensional vector consisting of pair of integers, right? Now I am just going through this for loop. I am taking m inputs, and those are x, y, and w. I am decrementing x and y because I wanted to take zero-based indexing, and I am just pushing these two things in my graph. That if I am pushing x and y, then the weight should be w. If I am pushing the inverse edge, the weight should be minus w. I initialize my visited vector with all values set to false, and I initialize my distance vector. Now, if the values are not visited, I can just try to visit it, and OK is going to store my final answer, right? So the value of OK will get updated by this DFS call. So this DFS call is actually going to return a Boolean value, and what I have to do is, basically for each of those DFS calls, again I have an OK variable, and I mark my current node as visited, right? Now I just traverse through all the children of the current node. If this child is not visited, I'll update its distance, what is the expected distance of this child, and I'll update my OK variable as OK is OK and DFS of child, right? So I'm using and always here and here, because if even one of those DFS calls return false, the whole answer will be false, right? So if it is already visited and the calculated distance is different than the expected distance, right? These two values are different, then I can just directly return 0 from here, because it is going to be false anyways. Otherwise, I will return the value OK from here, right? So again, I'm also taking and with all the values of OK, so that even if one of the values is false, then the whole answer will be false. At the end, I can just print if OK is true, then I can print yes, otherwise I can print no. So this was all about today's contest, and we've discussed the solution to all the problems. I hope that you guys were able to understand the solutions. If you guys did, then consider dropping a like on this video, and don't forget to share thoughts in the comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you and you'll be able to reach more number of people like you who want to keep solving new problems. So I see a lot of people who watch these videos have not subscribed yet. In case you're one of them, then definitely consider subscribing. It's always free of cost. You can also subscribe if you don't find the videos interesting later. So share the channel with your friends. Until the next video drops, keep coding, stay safe, bye bye.